So welcome to this talk on the future of machine learning and JavaScript. My name is Asim Hussain, or Awesome Hussain. You can find me on Twitter as Jawache, not Joashe. I blog about Angular and JavaScript on my website, codecraft.tv. And I'm something called a cloud advocate at Microsoft. And actually, I remember, as I was looking at these slides just today, I remembered that 2 ng-confs ago, I was sitting in the coffee shop over there being interviewed by John Popper for this new cloud advocacy role. And 2 ng-confs later, I'm now leading cloud advocacy for EMEA. Just want to thank ng-conf, and I just want to thank John Popper for the opportunity, and also Joe Eames for making the connections. I also have a saying. It's like, don't use your power for good, abuse your power for good. So I'm going to abuse my power on stage here right now and talk about a charity that I work with. So I work with a charity called Internship. And what they do is they find internships for Palestinians in high-tech Israeli startups. And I mentored 10 of the interns last year, and I'm very proud to say that this year, 17 of the interns are going to be mentored by one cloud advocate. So if you work with, or you work at, or you own a high-tech Israeli startup, and you're looking for interns, or you have openings for interns, please contact me. I can put you in contact with the program director, and we can get started. So to talk about my journey of last ng-conf to this ng-conf, this slide probably sums it up. There you go. This is Asim. This isn't my slide. This is actually my friend Eleanor Haproff's slide. So Eleanor and I go back a very long way. And we're both into JavaScript and both into machine learning. And at the start of last year, we launched a meetup group in London called the AI JavaScript Meetup Group. And we ran quite a few. We've run quite a few events over the since that time. And what would happen is people would come up to us and they'd send us links to JavaScript-powered AI applications. And we thought to ourselves, there needs to be a place online we can put these applications. And that's what we did. We created a website called AI-JS Rocks. And if you go to this website, you'll find a collection of AI-powered JavaScript applications. Because it's JavaScript, it means you can always click on it, play around with it in the browser. And also, because it's JavaScript, it usually means you can view source and look at the source code and find out how it was built. So it's a good place to go to be inspired and then also to learn a little bit about machine learning. And what I'm going to do today is going to talk about two applications that are on the AI-JS Rocks website. I'm going to explain how they were built. And through that journey, you're going to learn a little bit about machine learning and JavaScript, what's happening right now, and what are the options you have available. So the first application is this one. If you look at my T-shirt right now, it says something. It says, what does it say? It says, puppies, Azure, and I'm fine, which is a very, very long story as to why I'm wearing this T-shirt. But I was wearing this T-shirt about 6 months ago when I was giving a workshop in London. And one of the attendees, Oliver, went away and created an application based off of what I was teaching, and he called it TensorFlow MobileNet, and I'm fine. And I'll just show you what it is. It's running quite simply in a CodePen. It does a an Unsplash search for an image. So it's searching for puppies. And then it puts the image there. And then if you look in the bottom left-hand corner, it's trying to guess what's in the image. So here, it's not doing a good guess. Puppies, 9% terrier. I'm fine. What's that? T-shirt, isn't it? Yeah, 78% a T-shirt. So the really important thing about this application and the cool thing about it is that detection of what's in the image is all happening in the browser using JavaScript. Which is quite crazy, really. 10 years ago, we couldn't tell the difference between we couldn't tell if an image was a cat or a dog. Now we can do all this other stuff in the browser in JavaScript. It's built using a technology called TensorFlow, which Google outsourced outsourced. That's not the right word, is it? Open sourced in 2015. And it's a technology which you can use to, run mathematical equations across hundreds of servers and across GPUs and CPUs. And one of the things it's really used for is to build neural networks, which we all know what a neural network is, right? No? OK, I'll explain a little bit. So a neural network has a basis in biology. This is a neuron, a single neuron. We each have at least one of these. I couldn't guarantee that you have more than one. But I know for a fact that you each at least have one of these. Maybe you'll have less of them after tonight's party. But it has some dendrites going in, a body, and some axons going out. And what happens is, if enough electricity flows into the dendrites, the body fires some electricity out of the axon all the way out. That's it. That's a neuron. That's what it does. If I asked you to code this up yourself in JavaScript, you'd probably try and remember what it was like to be, if you went to university, a university student, desperately trying to remember your graph theory. And that's what you do. You basically create a node and some edges, clever, edges coming in and some edges going out. And then what do? You basically would pump in some electricity. What is that electricity? That electricity is some features. Maybe it's the day of the year and the current temperature in Celsius, which is the correct metric to measure temperature in. And if you want, I'll talk about Europe as well a little bit. But what it also will do is it will then take these inputs, take this electricity, how much of that matters in the eventual equation you would use, it decides via weights. So each of these edges have a weight assigned to it. Okay, that's it so far. Then you multiply these inputs together by the weights, sum them up, and pass them into something called an activation function, which is just a function. And whatever this function returns is what you pass back out. That's electricity going back out. This might be a single neuron that's trying to figure out the number of crickets that are chirping given a certain day and a certain temperature. Okay? Just to see a little bit more about how that might work, that's it. Just a bit of multiplication. Oftentimes when I give workshops on machine learning, everybody's like, it's just multiplication. And like, yeah, it's just multiplication, right? A little bit of addition, not much else. But what you do with a neural network is you basically combine a bunch of these together. This is a very, very simple 4-layer network, one input layer, one output layer, 2 hidden layers, but just the same stuff as you saw before, just edges going between each of those nodes. You would then initialize those edges with just a random number, math.rand. And then you start off with, what is this neural network doing? So let's say this neural network, we want it to learn how to detect if an image is of somebody who's happy or somebody who's sad. We then get a data set of images. We would then perhaps calculate the features of the face. So for instance, the positions of the eyes, the nose, the lips, the mouth. We would feed them in as inputs. And we're just doing that multiplication. That's all we're doing, multiplication. And it's giving us a number at the end. What does 3 mean? 3 means what we want it to mean. Maybe we want 0 to indicate unhappy and 10 to indicate happy. So this is actually telling us this is quite an unhappy person. But it's not, because we know. We know that this image is 8. We know that this is a happy image, because a human being has looked at this image and gone, yeah, that's 8. So we know this neural network's wrong. Of course it's wrong. We initialize it with random variables. We know it's wrong by 5. The secret is something called backpropagation. It's this process of tuning those numbers. We're tuning them. And that's what you do. You tell it how wrong it is, and then the backpropagation algorithm then figures out how to adjust these edges so that then when you pass in an image in the future, it tells you how happy it is. That's the process. That's what's happening with machine learning and neural networks. Just a lot of multiplication, and you're tuning these numbers, just tuning numbers. There's nothing magical. So that's a neural network. That's what we use TensorFlow for. So TensorFlow is actually written in C. It's really hardcore. It's built for doing deep number crunching. Last year, they announced TensorFlow.js. Okay? That's what we all love. It's that little .js at the end of everything. So TensorFlow.js. Now, when it first was released, I thought, OK, it's just bindings to TensorFlow. You need to install TensorFlow to use TensorFlow.js, and that's not true. TensorFlow.js is a complete rewrite of TensorFlow in JavaScript. Why is that important? It's important because this is all you need to do in order to do machine learning now in JavaScript. Just one dependency. Either if you're doing it properly at the top, that one. If you're doing it the way I like to code, you use this script tag at the bottom. And that's how it works. Now, what can you do with TensorFlow.js? You can do pretty much everything you can do with TensorFlow. You can train models, and that's what I showed you how to do before. Just that training process. You can do that. Or you can load pre-trained models, and that's what we love to do. That's kind of like coding up an application from scratch or searching NPM for a module. Now, there's quite a few that you can, if you go to the TensorFlow.js website right now, you can find that there's a bunch of pre-trained models that you can find and use, and that's what Oliver used for his demo. He used something called MobileNet. And what MobileNet is a very, very simple neural network that has been trained in order to identify only 1,000 things. It's not very good, but the trick is in the name, mobile. It's like small enough to be loaded up from within a browser and in a realistic way in order to use. But that's it, just like 4 lines in order to get all that incredible, powerful functionality in the browser. But you're making a trade-off here, OK? You're making a trade-off in size, something that's small enough to be used in the browser, but it's really not that useful if you really, really want to know what's inside an image. Because those models that can tell you in depth, can tell you tens of thousands of things that are inside an image, those are incredibly large, too large in order to download realistically into the browser or run on a browser. And usually, all the different cloud providers have various APIs that they provide to give you access to those kinds of services. I'm at Microsoft, and the service that we have is called computer vision. It's just an API that you can use where you can pass an image, and it tells you what's inside the image. I do think we need to change the marketing image here, though. Somebody who looks a little bit less confused. But so what can you use this for? My friend now, used to be my colleague, my friend Sarah Drasner, had quite a good idea for what to use this for. So we all know in images we're supposed to use alt text for screen readers so that they can read the text for accessibility. So she had the thought, well, can you use the computer vision API to automatically generate the alt text for your images? And one of the things this computer vision API can do, and that just boggles my mind, is it doesn't just tell you what's in an image, it gives you a textual description as if a human is talking to you and explaining to you what's in the image. And she created another demo, like a CodePen, in order to demonstrate how this works. So this is, if you load up a CodePen, it brings up this image, and the alt text at the top is generated by the computer vision API. So it says a black and white photo of Thomas Edison. The text says, hey girl, did you just share electrons because I'm feeling a covalent bond between us? Any chemists in the house? Is this funny? I don't know. I have no idea. But the thing that kind of blows me away about this is it doesn't say a black and white photo of a guy or a person. It knows it's Thomas Edison. That's kind of crazy, right? But as we all know, on Twitter, there's some very, very helpful, supportive people on that platform who, when you post something, will just support you and let you know when you've done things wrong. And obviously, there were some people that told her that it doesn't quite work as expected. So here's somebody who said, well, for this image, it says a star-filled sky. The text says 4 with some characters. It's all right. The next one, I think, is could be true. Could be true. I mean, they could be dead stuffed animals. You don't really know that, right? And I like the next one because according to me, 50% is a pass grade, and we got it 50% right. So yeah, so even big APIs that we've got, even big models we've got, sometimes get it wrong. Oh wow! So to summarize, TensorFlow.js doesn't have any dependencies. If you're going to take away one takeaway from this talk, that's a takeaway that you should take away. If you want to start doing machine learning in JavaScript in the browser, you can just drop that in and start going with it. MobileNet is a really simple way to get started. It's always how I start my workshops. But it is small and you're making trade-offs. If you really, really want to do something with image analysis, then I recommend using an API such as the Computer Vision API from Azure. Moving on really fast because I'm being quite slow. My next, and this is my favorite demo. It's amazing. It's called Image to Image. So you can find it on the AI.js Rocks website. And let's just see how it works. This is actually running in the browser. So yeah, you can draw the outline of a cat, and it will fill in the rest of the cat. Okay? It's made by a gentleman called Zaid, who's still a student in Saudi Arabia. I don't know what I wasn't doing this kind of stuff at university at all. How does it work? Right? And I think this is fascinating. It uses a technique called a generative adversarial neural network. And I'm going to teach you how this works. I think these are fascinating. The technique's only been around for about 2 years now. Has two neural networks which compete with each other. They're battling each other, okay? You've got a generator, and you've got a discriminator, okay? The generator's job is you feed in some inputs. Inputs are the outlines of cat images. You have a set of outlines of cat images. And its job is to generate an image of a cat. But it's not going to do a very good job, is it, initially, because it would have been initialized with random math.random. So it's not going to do a really good job. But anyway, whatever. You get all of those cat images. You combine them together with a bunch of real cat images. And you mix them all up. And you send them to the discriminator. And the discriminator's job is to figure out if one of these images is of a real cat or of a fake cat. And if it got it wrong, like it got it wrong here, it said that the real cat is fake, then you know the discriminator isn't working very well. And what does it happen when it goes wrong? We have to tune the numbers, and that's what happens. You tune it. It learns to become a little bit better. But then, if it did get it right, then what does that mean? Well, it means the generator isn't doing a good job of generating cat images. So the generator then does a better job. And what happens, they keep on fighting against each other, against each other, against each other. The discriminator gets better, the generator gets better, keeps on going, keeps on going, keeps on going, until the discriminator can't tell anymore if an image is a fake image or a real image. And then what you do is you throw away your discriminator. You don't need that anymore. You take your generator, and you can export that as that JSON format, and you can load it up in TensorFlow.js and use it from within the browser. And that's what they did. Okay, that's how it works. So, okay, cool. That's fun, right? Generating cat images. What's the point? Like, is that really impressive? Well, how about this? These images are generated from the outlines on the left. And the previous thing that you saw was an algorithm called pix to pix. This is a different algorithm called vid to vid. This doesn't run in the browser yet. Yeah, you always have to put yet when it comes to browsers and JavaScript, don't you? But yeah, so again, generated. How about this one? One input, multiple outputs. The input doesn't just have to be outlines of things. The input can actually be anything you want it to be, anything you want it to be. This is another example. The input is what's called a segmented image. So the different colors define kind of a depth to the image. And what you can do with this is this. Okay? She's not dancing. That's a generated image from this. I love making people silent. It's always good. And as I said, the input doesn't even have to be an image. The input could be anything. It can be text. It can be text. So the input here is just a text on the top. So the flower has long, thin yellow petals and a lot of yellow anthers in the center. The top images are after 600 iterations. The bottom images are after 1,200 iterations. The same with the birds here as well. They're generated from the text. This one's not that great, but the rest of them, pretty good, right? How far away are you? How far away do you think we are? Really, how far away do you think we are from somebody typing in a field, build me an e-commerce application with 4 pages, PayPal for payments, go. Remember, 10 years ago, we couldn't tell the difference between a cat and a dog in an image. Even more silence. Excellent. Just to summarize, GANs learn to generate new images. They're generative, okay? They require a lot of compute to train, a lot. You can't really train those kind of GANs in the browser. But the generator model that you create can actually be exported and optimized to be able to run in the browser. So just another thing, just before I finish, I'm thinking of writing a book on TensorFlow.js. If you're interested, let me know. Just go to that website and just sign up. I haven't committed to it yet. So let me know if you're interested in something like that to sign up. You can take pictures. I'll leave it up there for 10 more seconds. Enough. If you want to also learn a little bit more about how to use maybe some of those APIs that I showed you today, I have a really good example called the Emojifier. And this goes to a tutorial where you can go online. It'll show you how to do, it'll show you how to basically put emojis on people's faces matching their emotion. Pretty revolutionary application. And that's it. Thank you very much for your time. You can follow me on Twitter.